Now we're going to be using the other part of the handout I gave you yesterday. Now, was anyone not here yesterday? If you weren't here yesterday, I have a handout that covers yesterday and today. So now I'm going to be using it during this presentation. All right. When you get into your next chemistry class, frequently they'll have you memorize how you really do. And they're kind of a pain to use. That's why I made this chart, because this chart is not a pain to use. It's very, very easy to use. And I don't know if your next teacher will allow this to be used in their class or not. So you have to kind of flow with it. If you know you're taking 1A, I would start off by looking at the rules when we do the double replacement lab. Use the rules and double check with the chart. Because you're probably gonna have to use the rules in 1A. Just the way it is. When I taught 1A, I used this chart, however. Okay, how to use this chart. Basically, let's talk about the difference between these two reactions. What we did yesterday was called single replacement, and it involved a metal and a salt, like silver metal and zinc +2. Okay, today we're just doing salts, just salts. And this is what the concept of what we're going to be doing. Okay, so silver nitrate, AgNO3, sodium chloride, both those are salts. Now, when you say salt in chemistry, we're not talking about common table salt. We're talking about a much, much, much broader class of chemicals where we have an anion and a cation, a positive and a negative ion. That's a salt. Now, what a double replacement reaction is we're going to take two solutions with a salt dissolved in there, like silver nitrate, sodium chloride. We're going to dump them together. And then something may or may not happen. We may get a solid formed or gas released, or nothing will happen. And that's where the chart comes in. The chart will tell you whether something's going to happen. Now, qualitatively, there are two forces at work here to determine if you're going to get a solid. In other words, we put sand in water versus putting sugar in water. What's the difference? Sugar dissolves, right? Sand doesn't dissolve. Why? These two forces will tell you why. One is called a solvating force, and that's the force that pulls the crystal apart. Then there's a crystal lattice force that keeps it together. Now, in the situation of sand, the crystal lattice force is stronger than the solvating force, so it stays together. In the case of sugar and water, the solvating force is stronger, so it pulls the crystals, the sugar out of the crystal. So those are the two competing forces. Crystal lattice force is not affected by temperature. Solvating force is. In other words, hot water dissolves more sugar than cold water because the solvating force is increased by temperature. Okay. Some people say there's a solid formed when you dump these two together. Other people say a precipitate forms. They're one and the same. One's abbreviated S, the other's abbreviated PPT. And you may use either one. I usually say precipitate, but write S. Okay. All right. So this is a table of cations, anions. Anions on the vertical left, cations across the top. Aqueous. That means it's dissolved in water. You said AQ, right? Yeah, aqueous. Okay. So if we have two ions, an anion and a cation, what we're going to do is we're going to cross and where they cross is either going to be black or white. If it's black, that means a solid forms. If it's white, that means nothing happens. If it's white, that means the solvating force is strong. If it's black, that means the crystal lattice force is strong. Now we're going to use that in a situation like this. Okay, silver nitrate, if we look on the table, we find silver and nitrate, white. That's why there's no solid in that one beaker. Sodium chloride. Sodium chloride, again white. That's why there's no solid in that other beaker. When we dump them together though, there are two new possibilities of hooking up. Silver with the chloride and sodium with the nitrate. Okay, so we have silver and we go down to chloride, which is right here. And it's black. That means the silver and the chloride will form a solid. Sodium nitrate is the other pair. There's nitrate and sodium again, white. So that's not going to form a solid. Now, sometimes you form two solids and you can't distinguish between the two. Maybe they're both white or both yellow or something like that. So that's how to use this chart. Again, AQ means it's dissolved in water. Dissolved. That means the ions are separate. So this is the same thing as saying that. Okay. So we have one beaker of zinc sulfate aqueous. Okay, and another beaker we're going to have calcium nitrate, also aqueous. Yeah, we dump those two beakers together. What happens? Well, we have a new combination available. We have we have the zinc and the nitrate now can hook up, and the calcium and sulfate can hook up. The either one of those form a solid. Well, we go to our solubility table. So we have zinc sulfate, zinc, zinc sulfate's white, and calcium sulfate is black. So when we dump those two solutions together, we're going to get a solid. We can't tell from that table what color the solid is. Frequently it's white, but not all the time. So we would write this now. Like that. Now, yesterday we talked about spectator ions. Frequently in a double reaction question, you'll be asked, what are the spectator ions? Well, spectator ions are ions that don't do anything. Now, the sulfate is not a spectator ion because it solidified with the calcium. But the nitrate, the NO3, is aqueous on both sides. So NO3 is a spectator ion, as well as the zinc is. Now, we have something called a net ionic equation. The net ionic equation is, did something happen? In this case, yes. Write the equation. Well, what happened was we have calcium plus sulfate. So that would be the net ionic equation. Sometimes they'll say NIE. Lots of three-letter acronyms. Now, in your next class, they're also going to ask you to write a total ionic equation. What that means is we're going to split everything up. Right now, this is called the molecular equation. The total ionic equation we're not going to do in here, but your next class probably, for sure 1A, question mark for 2A. Depends on the instructor. But basically what we're doing is So this will be called the total ionic equation. Now, whenever we write equations, we always have to make sure they're balanced. So, and then TIE. So you have molecular equation, total ionic, and net ionic spectator ions. So again, here, just know that exists. And the reason I do that is I want you to focus on either the rules or the table, what happens when we mix stuff together. You get new combinations, and the new combinations could sometimes mean a solid, sometimes nothing. And sometimes you dump the stuff together and nothing happens. So that would be a nothing happens, null set. Now, you still have, that means everything's a spectator ion. That happens. An example would be so then now we're looking at so in this case, no visible reaction or null set. And that means everything's a spectator ion. Now we're going to have a really nice lab on this after break for yesterday's single replacement and also for today's double replacement. It's students say that's their favorite lab is the double replacement because you're doing it with drops and colors change and you get to predict and stuff. It's students really like it. Okay, well that's double replacement reaction. So, any questions about this? Yeah.
Why are nuts? Um,
The total,
yeah, the total, simple, why,
because I want to focus on putting things together and seeing if you get it solid or not. If everybody gets hung up on that, just all these little details. And you can do it if you like. What class are you taking next? Why don't you do it? Just to get used to doing it. But that's why I leave it off, because it adds a lot of complexity that it really doesn't do anything. It just shows the ions versus a molecular one. The ions are there just bound up. Yeah. So I don't think it adds anything, but a lot of teachers teach it. Well, like I mentioned. So, does that make sense?
yeah,
And you'll thank me too. All right. All right, that's it for today. I want to remind you the test, I got your message regarding practice test, but I didn't do it. Because I left my computer in my car. And anyway, it's not an excuse, it's just what happened. All right, so I will post a practice test for the October 25th test coming up. I'll also post a study guide. And the practice test is the same as a study guide almost. So that's what's coming up. Now, if you're interested in doing a first or an extra credit poster, I recommend you doing it over break. And also study material for test 2. Ask me, if you are thinking about a topic, just talk to me about it and we can, most of the time, if not all the time, we can usually work it out so you can do your topic. Because chemistry is basically in everything. It also can be biochemistry or organic chemistry also. Okay, so that's it for today.